Hello everyone. In this video, we will introduce the notion of parametric equations, and we will show that how these equations are going to define us curves which are more general than the graphs of some functions. Well, the source of parametric equation comes from studies in physics. So if you consider a particle moving on a screen, or just consider the tip of my pen here, which now moves on this screen. Okay, so you want to study that. There is no function that can give this curve as the graph of that function. There are tons of reasons for that. For example, the vertical line test, this curve doesn't pass. But what we can do is that at any time t, the pen leaves a point on the curve, and this curve is basically the set of all these points. But for each one of these points, which are going to be described by first coordinate and second coordinate, we can say that what happened or when this point occurred at very first time, so time 0. This point was when time was t. This one was just as an example. Time was 2. Sorry, yes, and well, at time 3 we got to this end point or terminal point. So you see that to describe this, it's very natural to start with the third variable. This third variable can be time, especially when you study the physics, or in mathematical setting, this is just a third variable. So a parametric equation I should write equations is a set of two equations. We need one equation to describe first coordinate and one for the second one, that defines coordinates x and y as functions of a third variable. Well, here I use t, what in general can be s, can be u, whatever third variable you want, which has a name, it's called a parameter. So in other words, we have one gives x in terms of t, and one which gives y in terms of t. And then when you put the points defined by these guys, so the set of all points where first component is given by f at t, the second component is given by g at t, form a curve which is called a parametric curve. As I said, there is a physical reason that we study these guys, and mathematically it's very nice. We will see different things, how to differentiate, how to find tangent line, how to integrate for some specific things, these kind of curves. But before everything, before all those interesting calculus come in, we have to do some examples, see how these guys define some curves. Very simple examples. I have 3 of them here ready for you. So x is 2t plus 1 and y is t minus 1. So the starting point is that you will learn more tricks how to study these guys. But for now is that, okay, I put different values of t for x and y, and for each t I will find a pair of points, x and y and x and y, and I will trace those points on the plane and then see what kind of form we have. For example, I would just use integer values. You can put any values in between, actually, like that. Okay. And well, x here, if I plug in t negative 2, there is negative 3, and this is negative 3. For negative 1, this is going to be negative 1 and negative 2. This is going to be 1 and negative 1. This is going to be 3 and 0. And the last one is going to be 5 and 1. So I have 5 points, negative 3, 3, negative 1, negative 2, 1 and negative 1, 3 and 0, and 5 and 1. The first thing you see, okay, I don't know what are these guys, but if you sketch them on a coordinate system, you may find a good pattern for them. So I'll try to see if I can do it here. So you see, to find x and y, I need the parameter t. But when I want to sketch it on the plane, the only thing I need is these x and y values, or the point, a pair of points. For example, for t equal to negative 1, negative 2, this will give us negative 3 and 3. I can write t equal to negative 2 there. Yes, for t equal to negative 2, we get negative 3 and negative 3. For t equal to negative 1, I get negative 1 and negative 2. Well, should have written this one here. For t equal to 0, 1, and negative 1, then there will be 0 and 3, and there will be this guy here. So for different values of t, I'm just writing these ones to have an indication of what are the values, but in general we don't need to write those values of t there. Yes. Now, as you notice, the pattern here is that, yeah, they are moving on, at least it seems like that, yes, on a line. And if you increase the number of values of t, you will see that, oh, these equations defining us a straight line. And as you see, as t increases, the curve is basically traced from left to right. Yes, that's true. So you can describe curves or straight lines using very explicit equation, y equal to some multiple of x plus constant, or parametric equation can also give you some lines. We will study a little bit more on these cases. Another example is a little bit different example. Here, the first component is going to be a 0 all the time. So it means that our curve is going to be part of our y-axis. So this is x, and that is y. Yes. But how does this work? Okay, few things you can know here, but let me just find the values and then go from there. Okay, so now I know that for all values of t, x is 0, but y is given by cosine t. So I'll choose values of t such that I get good numbers here. So for example, I can start from 0, then I go to pi over 6, then pi over 4, then pi over 3, pi over 2, and continue. So for this one, for all of them, x is going to be 0. So in other words, x is independent of t. The second one, however, this will give us 1. This will give us root 3 over 2. This will give us root 2 over 2. This is half, and then this will be 0. So if I start, so if this is 0.1, let's say, Then if I start from a t equal to 0, this is the point. Then t equal to pi over 6, it will get somewhere here, and then somewhere here, and then this, and then it will continue at t equal to pi over 2. It will stay there. Now, if I increase values, it will go down up until it gets to -1. That's when t is pi. But since you know that cosine is between 1 and -1, so it means that our curve, parametric curve, is not going to go beyond these points. So our curve here is basically this line segment. And well, the parametrization doesn't give you one direction, so it will go down, and then when you increase, it will come back up. So it will basically oscillate between these 2 points on that line segment. Okay. How about this one? Well, this is another interesting example that we will cover here. In this case, you see that t and x are the same thing, though I have different values. Well, by the way, t is supposed to be between 0 and 4, so I will go integer values of between those 2 values, 0, 1, 2, 3, 4. Note that I can use any other real number between these 2 numbers. I'm just fixing some points, yes? Whatever you put for t, x will be the same thing. And then values of y, here will be 0, here will be -1, here is 0, here is 9 minus 6 is going to be 3, and that is 16 minus 8 is going to be 8, yes? So now I want to plot these points and see if I can find a pattern for that. Okay, so the points are 1 here, 1 almost there, and then 1 there. Then there is 1 here. There will be something up there as well, somewhere there. Okay, and that's the end point. You might say, okay, I cannot see any good pattern. But if you increase the numbers, well, let me maybe say something else. Here I know that x and t are the same thing. I can combine these 2 equations, then write it as y is equal to x squared minus 2x. So this is a parabola. Well, yes, it is equation for the parabola. But interestingly, it won't cover the whole parabola. It will go from t equal to 0, which gave us this, t1, t2, t3, and t for the end point will stay there. So this equation, as you see, I was able to get rid of the variable, the parameter t, and write it as a parabola, and it forms part of parabola. The trick here, we will work a little bit more on that in other videos, but for now these are just basic examples that shows you how these parametric equations are given.